So shapes, nets, triangles and angles. It's more information than actual doing work, this, to be perfectly honest. It's just some information. So we're going to look at shapes, angles, nets of shapes and triangles and some plans and elevations, some angles and some coordinates. We've already looked at coordinates, we know all about that. Again, it's available to watch, or it will be available to watch on YouTube. These are the most common shapes that you're going to come across in the maths exam. Okay, so it's important that we've got a good understanding of what they are. Obviously circle, semicircle, half circle, triangle, rectangle. A triangle is half a rectangle or half a square. Parallelogram, which basically is that rectangle but you just pushed it over a little bit. A pentagon, it's got 5 sides. A hexagon has got 6 sides. The oval and the trapezoid, which looks like a triangle without the top on, basically. Again, it's a 4-sided shape. 4-sided shapes are also called quadrilaterals. So they're the 2-dimensional shapes, often associated with area questions. Squares, circles, semicircles, triangles, rectangles will be associated with area questions, the most common ones. If you just get a question what says, like it's just said on that coordinates question, draw a parallelogram, you know what one looks like. Yeah, you never know what one looks like. Okay? So, first of all, what formula would you use to work out the area of a triangle? Can you remember?
Base times height divided by 2.
What would you do to work out the area of a semicircle?
Work out the area of the circle and then divide it by 2.
Well, you work out the area of a full circle, which is pi times radius, then divide it by 2. Yeah. How could you best describe a parallelogram?
It's a quadrilateral.
It's a rectangle that has been pushed over slightly. Yeah?
Would the accent wonky?
Yeah, it probably would. It probably would. How many sides does a pentagon have?
5.
Yeah, look at that. So we just remember.
So confused with the shape.
Yeah? Okay, 3-dimensional shapes. Now these are more often than not associated with volume. And again, these are the 5 or 6 common ones that are actually used in the exam. Your cube and your cuboid, really popular ones. The pyramid and the prism, popular. The cylinder is very, very popular. You would need to know the formulas for those, not the pyramid. You'd need to know the formulas for these 3. The cube and cuboid, the cylinder and the prism. The sphere, the pyramid and the cone, they would tell you the formulas for. Okay? Don't expect you to remember all 7 formulas. But again, those are the shapes. Look at the difference between the prism and the pyramid. Okay? There is a difference. That's 3 sides, that's got 4. Okay? So that's the difference between the 2. Okay? What's the difference between a pyramid and a prism?
The sides.
The sides.
Yeah.
A pyramid is a square base and a prism has a rectangular base. Yeah? Are a cube and a cuboid the same?
No.
No.
No. A cube has sides of equal length and width and height. A cuboid is rectangular with varying length, width and height. Now I'm going to test your memory from a few weeks back. What shape is the side of a cylinder?
A rectangle.
It is, yeah. It's a rectangle.
Cut
Remember
it out,
we fold
didn't
it
we?
round?
Yeah.
Yeah, asked you to think back a little bit there. Nets. Okay. Not dead common in the exam, but we need to know what they are. A net is just a 3D shape that's been folded out flat. So for example, that's a pyramid. Yeah? There's the square base, there's the 4 sides. If we were to fold it all back together, it would look like, if we open it up, it looks like that. Yeah? Let's draw a net of this cuboid. Okay? The cuboid has 6 faces. So a net for the cuboid will be made up from 6 rectangles. Draw the rectangle for the bottom of the first cuboid first, and then draw the rectangles for the sides of the cuboid, and draw the rectangles for the front and back of the cuboid. I don't think I've got it on as a picture. Finally, draw the cuboid with the same dimensions as the bottom. So what would you do for that particular question? If you had to draw that as a net, here's your bottom of the cuboid. There it is, that's the bottom of it. You've got a side here, okay, which is 5 centimetres tall, okay. The length of the cuboid is 11. There's the other side. So you've pulled it, opened it down, yeah? One edge. There's the two ends that you fold up, and then here would be the top. So you fold the two sides up, and then the top folds over the top. Does that make sense? Yeah? So that's what it would look like. 1, 2, 3, 4, 5, 6. Bottom, side, or front, back, side, side, top. Just imagine you open a box up. Think to yourself, if you're doing a bit of recycling, you've had a box of loo from Amazon and you need to get it in the bin, just open it up. Yeah, you could do that at home, you could practice it at home, no problem at all. That's the net of a cylinder, top, bottom, side, we know it's a rectangle. That's the net of a pyramid, square base, 4 sides. Imagine you just pull all them up together, it makes a little curve. Okay. Let's work out the surface area of the cylinder. Okay? Because nets can be used to find surface areas of 3D shapes. Let's work out the surface area of this cylinder. Well, when we broke it down into a net, we know how to work out the area of a circle, pi times r squared, pi times r squared, length times width. Yeah, length times width. Remember when we did this activity, when we did area, this was the missing piece of information, wasn't it? And we found that out by, what did we find that out? By working out the circumference, didn't we? So we worked out the area of the top, pi 3.14 times by 7 times by 7. Then we work out the area of the bottom, it's going to be the same as the top. And then the circumference of the top gives the length here, remember, because when we did it, and we opened it up like that, if you remember doing that in the class, but when we took it, I can't use that because it's got a bit missing. There's the cylinder, when we open it up, it's a rectangle. So we know that the height of it is 11, but to find this bit, we'd have to use the pi times diameter because that's the actual circumference of that circle. Remember that from when we did area. Okay? When we did area. The area of the rectangle. Which is, and then you add them all together. At the top, the bottom, and then the rectangle. And we add them all together. Okay? For this particular example, it gives us an answer of 791.28 centimetres. That makes sense, yeah? Do we need to do it as an example, just to show you have we got the numbers? Are you quite happy with that? Yeah, do it, okay.
I'm a little bit confused, or I can't remember about
Can't remember.
the rectangle, finding that length. We've got the 11, but... Yeah.
So, we've got our cylinder. It's 11 centimetres tall. So the net of our shape, top, cylinder, bottom. So we know that the radius, which is what we need to work out the area, is 7. So we do pi times 7 times 7, okay? We know what pi is, don't we? 3.14. Let's get the calculator. .14 times 7 times 7. 153.86. 153.86. That's the same. So now we come to working out this, the rectangle. Now we know that it's 11. So we know that a rectangle, to work the formula for working out the area of a rectangle is the length of something times by the width of something. We know the width, it's 11. What we don't know is this number here, that measurement there. So what we imagine, I can use my ruler as an example, is that that's a rectangle. That is now a cylinder. So to find out this distance, this length here, which is the top of this ruler, is when you open the ruler up, it's going to be the length that we need. But when the ruler's rolled back up again, what's that measurement called? What's that called that's round the top? It's called the circumference, isn't it? Yeah?
Right, right.
So if we can work out the circumference of
Yes.
that circle,
Yeah,
it'll give us
I'm with you.
the length. So to find that measurement there, we need to do pi times diameter, which in this case
Yeah.
is 3.14 times by 14. Remember, that's only going to give us this measurement, it's not the answer to the actual sum. Right, calculate 3.14 multiplied by 14, 43.96. So that measurement there is here. Now we can work that out. 43.96 times by 11, 483.56. So we've got the top and the bottom. We've got this bit here. We just add them all together. Yeah, we just add them all together, which comes up with 791.28. So that's how you would, if you got a net of that shape and you had to work it out, that's how you would work it out. And I think that's easier than trying to work out that, because you can actually see the three shapes: circle, rectangle, circle. So you then physically could think to yourself, yeah, I know how to work that out. I know how to work that out, because that's the same as that. And then that's a rectangle, length times width. Whereas when you see it like that, it's a bit more confusing, because you've got to remember that that is that, and you need the diameter to find that missing number. Does that make sense? Draw a net and work out the surface area of each of the shapes below. Okay? Do it on it. We'll do it on you. So we'll start with this triangle. So the net of that triangle there, pyramid, sorry, it's not a triangle, it's a pyramid, would look like this, wouldn't it? Obviously it's not drawn to scale. Oops. Okay, there's your pyramid. Alright. This measurement here is 9 meters. And this measurement is 13 meters. Okay? So the question is, what's the surface area of that shape? Well, what's the shape made up of? Let's work it out. Let's think about what that shape's made up of. It's made up of a square. We know how to work that out, don't we? Length times width.
Is it on?
Look,